Welcome to another wonderful video about air pollution. This is 7.6. Let's go. We have talked about air pollution and all of the issues that exist because of it, how it's being created. Now let's talk about how we can reduce it. There are four main ways. We can look at conservation practices. We can look at regulatory practices. These are the most efficient. We can look at mitigation technologies, and we can look at alternative fuels. Okay, so conservation practices, these are efforts made to intentionally reduce air pollution by using less fuel. These are often done by companies, by humans, by families, by communities, realizing that, hey, we have an issue at hand. We need to support our earth. We need to reduce the amount of air pollution. We need to reduce the amount of CO2. And so it could be cost driven, or it could just be altruistically driven decisions that are made to consciously reduce this air pollution by using less fuel. That's the biggest thing here. We're going to use less fuel. That could work in so many different ways. We could drive fuel-efficient cars. We could use public transportation. We could lower the temperature of our homes in the winter. We could eat locally sourced food, so this food doesn't have to be flown across the world on a plane. Or we could use energy-efficient appliances. Like I said, these are decisions made by families, by individuals, but they can also be decisions made by companies. And there's a lot of companies. Patagonia is a very famous one that has made a lot of these decisions to increase their brand loyalty and to say, look, keep supporting us because these are the decisions we are making to protect our globe. Here's a great example of some conservation technologies that have existed in my lifetime. You've probably noticed it. You just may not remember. Sometimes when you were a kid, when I was a kid, we had these incandescent lights. This is why Christmas trees would literally burn down because these lights were so hot. If you look at this here, it took 60 watts, that's 60 joules per second, to produce 80 lumens of light. And so this was a filament light bulb, and these light bulbs got really hot. If you ever had to change a light bulb, they were hot to touch them. That all kind of changed, I want to say a good 10, 15 years ago. We started seeing these compact fluorescent lights. And though these were great, they took the wattage from 60 watts to down to 14 watts. We need so much less energy to get the same amount of light. The issue is that these had mercury inside of them. So if they ever broke, they were leaking some nasty chemicals into the air. Finally, we've been dealing with LEDs for the last 30 years. And finally, LEDs went from being not just red and green and blue, they finally got some white LEDs. This was recent technology in the last, I want to say, 8 years or so. And that, again, 12 watts, little energy, especially when we compare that to the 60 watts, to get the same amount of light. Now let's talk about these regulatory practices. These, as I mentioned before, these are the most efficient in enforcing changes in air pollution. We saw this previously with the Clean Air Act, but these are laws and regulations imposed by a government for the purpose of reducing pollution. Governments are often the ones who are initiating these regulatory practices because they're creating these laws and regulations. Now, these laws and regulations can do two things. They can place limits on emissions, and they can give fines for companies that don't comply, but they can also provide tax write-offs and tax benefits for companies that are developing new technology to reduce air pollution. So as I mentioned before, these companies that are taking us from these incandescent light bulbs to the LED, these regulatory practices can help benefit them. So, ways for governments to incentivize companies who are doing good, but also penalize companies that are not doing great. We've talked about the Clean Air Act, but just a quick review. This was adopted by the US government in 1972, and it established the EPA, which is the Environmental Protection Agency. They set air quality standards and a timetable of phasing out leaded gasoline, which was a big deal. If you remember my last video, that leaded gasoline was officially phased out of our planet in 2021. Fantastic. They also set these national ambient air quality standards and have kind of become this first progressive group to say, here are the standards and you must stick to them. Because this Clean Air Act set limits on these other pollutants, it led to the development of some other important mitigation technologies, including catalytic converters and scrubbers for factory smokestacks. So let's look at these two. Catalytic converter, it's a device that is used in cars. And it has gone into the exhaust system of a car in order to reduce the emission of the pollutants. If you remember, because the nature of combustion, we are unfortunately pulling air into this combustion chamber, and air has N2 in it. That N2 during the combustion turns into NOx, which when combined with VOCs creates photochemical smog. Catalytic converters were created as a way to help prevent that. They use something called a honeycomb, this ceramic honeycomb. It's a honeycomb that looks like this. It's full of these metal catalysts. And they have implanted platinum and other metals into it that trigger these chemical reactions that are going to convert those pollutants like NOx and sulfur dioxide and carbon monoxide into less harmful products. So let's look at that real fast. Those of you from chemistry know that a catalyst is something that promotes a chemical reaction, but it's not consumed during the process. So these catalytic converters, they are using platinum, palladium, rhodium, super expensive metals. I mean, this is why these things cost $3,000 in the States to go into cars. They're super expensive because they're made of these super expensive metals to act as these catalysts for the reactions. But look at what wonderful things they do. Reaction number one, they take carbon monoxide, they combust it to create CO2. Yes, it's creating CO2, but CO2 is not as bad as SO2 or NO2. It's not one of those AAQI pollutants that we consider an air pollution. Number two, guys, this is a twofer. We get a buy one, get two free here. Look at this. One reaction, we killed two stones, two pollutants. NOx and carbon monoxide, we react them together to get nitrogen and carbon dioxide. That's a fantastic reaction. Wonderful. And then our VOCs. This is just the unburned fuel. We know that our engines are not 100% efficient, so there is going to be some unburned fuel. And that unburned fuel is our VOCs that are going on. So we're also going to combust out that unburned fuel to give us water and CO2. Fantastic invention. So the hydrocarbons, the carbon monoxides, the NOx's that have been created during that combustion go through this catalytic converter that costs us about $3,000, and it pops out the other side as N2, H2O, and CO2, which are much friendlier pollutants in our atmosphere. This reduces pollution by 90%. Absolutely incredible. Cars would be cheaper without it, but we would have 9 times the pollution. So absolutely incredible invention. In addition to these catalytic converters, another technology has been developed, which is called an industrial scrubber. And these are used in exhaust systems of factories and power generation facilities. Anything that is doing large amounts of combustion, we're going to integrate these scrubbers into them. And we have three different types of scrubbers. We have wet scrubbers, dry scrubbers, and electrostatic scrubbers, aka precipitators. At the end of the day, they're doing a very similar thing to our catalytic converters. They're removing the acid precursors, our NOx's and our SO2. And then our electrostatic precipitators, or electrostatic scrubbers, they're removing our PM2.5s and our PM10s. And these wet scrubbers, our exhaust is going to come through and it's going to meet this spray of water that contains bases pretty much that are going to neutralize these acid containing pollutants. So our SO2, our NOx, these things are going to be neutralized by sodium hydroxide, calcium carbonate, calcium hydroxide. And so we're going to mix together. So they come through, this solution of these liquids is sprayed onto these particles, and then everybody kind of falls together into this slurry. So then that means everything that is leaving is free of these particles, which is a really big deal. The downside of these wet scrubbers, though, is that now you have this really nasty concoction of sodium hydroxide, calcium carbonate, calcium hydroxide with some SO2. And it's just not a great, there's oil, there's soot, there's excess, it's just not a great solution. And now that wastewater has to be dealt with somehow. And as we'll get to in another topic, wastewater is another pollutant. So we, unfortunately, by cleaning the air, we create another pollutant, but at least we are cleaning the air. This is kind of a better way for you to look and see what's happening. So the gas comes through, it's trying to move upwards, but it's being caught by all this scrubbing liquid that is collecting those pollutants. They're capturing the SO2 and the NOx and the particle matter, and then that all ends up down below as our scrubbing solution, and that is drained out. But we get this gorgeous clean air, this clean exhaust. And these scrubbers are so efficient. They're removing 99% of the pollutants from our exhaust gases. That's massive. We did realize, though, that this wet leftover slurry is not great. It would be wonderful if we could find some other way. So then the dry scrubber was created. For a dry scrubber, exhaust is passed through a spray of I would call it a dry chemical powder. It's like pulverized, kind of wet limestone, and this kind of damp limestone. For those of you who don't like the word, I'll just write it out. It could even be this word. This type of limestone reacts with the NOx and the SO2 and kind of captures it from the air. After reacting, that the dry particles are filtered out of that exhaust stream, and then we're just left with the solid bits below. So we can see here, the dirty air comes in and it's mixed all in here. And that's where that vaporized limestone, that damp, moist limestone is just in the air, and it's capturing all of this SO2 and NOx, pulls it out of the air so that clean exhaust can move out from there. 98% efficient. Also fantastic. So it's pulling out 98% of the SO2. And most importantly, we have the advantage of not having liquid waste. That's a big deal. And finally, we have these electrostatic scrubbers. Those of you who understand chemistry and positive, negative charges, we know that negative things attract to positive things. So let me walk you through this. what happens is that a negative kind of like mesh is created here. This is a negatively charged mesh here. And particles that go through that mesh end up with a negative charge. Let me add that. They end up with this negative charge. So then they move through that mesh and they all of a sudden have this negative charge. And then they attract to these super positive boards here. Super, super positive. So they kind of just get stuck to these positive walls. So they're captured by these positive walls as they try to move through, and therefore they're pulled from the exhaust. Here's probably a better way for you to look at it. So here is the wall of negativity. So anything that goes through this mesh of negativity will become negative. And then all those negatively charged things, so all of our SO2s, our NOx's, and our particle, our 2.5s, and our PM10s, they're going to turn negative. So therefore, when they hit this area, they're going to turn positive and they're going to get stuck to these. And that's going to allow for clean air to move forward. This is how our air purifiers in our classrooms work. They're doing the exact same technology as this. So there we go. Lots of great technology going on here, and technology will only advance moving forward. So here's your next challenge, is to see how we can further eliminate pollutants from the air. Have a great night.